Oh, welcome and thank you for joining. We just learned how to find the derivative of the product of two functions, and now we're going to practice how to use it in an equation of a function given in product form. So here we go. In this example, we have ft is given as a product of two functions, 4t squared minus t with t cubed minus 8t squared plus 12. So to find the derivative of function ft, we're going to apply the product rule. Now, this is what the product rule states. So if you have the product of f times g, the derivative of it would be equal to, so first you write the products fg twice, and that's because you have two terms in the product, and then in the first term you take the derivative of one of the functions, the first, and in the second group of terms you take the derivative of the second. So that's the product rule in differentiation. So let's get to work. I'm going to start off with f prime of t. So that would equal the product of these two functions, and I'm going to write these products twice, just like I wrote the formula. And now I know that to find the derivative, I have to take the derivative of one of the functions here. So I'll take the first, and derivative of the other function here. So I'll take the second. So once you write out the formula of the derivative or apply the formula of the derivative into the function, you start differentiating. Now, with practice, you will drop this step. You won't actually find it necessary to write it because with practice we see things better and faster. But for now, obviously, I am writing everything down because we are trying to learn it, right? So we're at the beginning. So f prime of t then would be equal to the derivative of 4t squared minus t. Now remember that this is just application of the power rule in differentiation, and the power rule states that if you have x to the power of n, so a term x to the power of n differentiated, so the derivative of it would be equal to the coefficient, the power n becomes a coefficient, and the power of n on here will be reduced by 1. So nx to the power of n minus 1. So we'll use this formula to find the derivative of the first term here, or first function. So that means we have 4 times 2, 8. T will reduce the power by 1, so that would be power 1. So you don't have to write it. And then multiplied by t to the power of 3 minus 8t to the power of 2 plus 12. And then plus, so this function doesn't change, so you just rewrite it the way it was, no changes. Now we're taking the derivative of the second function here, so t to the power of 3 will have the derivative, remember 3 will become a coefficient, t will reduce the power by from 3 to 1 by 1, right? So that becomes a 2, minus 8 times the power 2, which is 16, t to the power 1, and the derivative of 12 is a 0, so that's when we close the brackets. Now we have to expand and simplify. And remember at the beginning of the course when I said that, calculus is very logical, it's fun, it's easy to see the connections, it's easy to understand the connections. However, there will be a lot of simplification. So this is from the previous grade. So simplifying polynomials, expanding, simplifying rational expressions, etc., etc. So, and we said that, we shouldn't let the little things, so the things from the past, get on the way to learning the bigger things, so build the future. So build new learning, in other words. So I know I used very dramatic words sometimes. Anyways, so we're going to go ahead and expand and simplify here. Let's see what we get. So this is simple. Oopsie. All our secrets about what we did before here. So this is the proof of the product rule in differentiation. So we are expanding and simplifying. This is simple expansion. So when we have two binomials multiplied, we call it FOIL. I don't know if we can call it FOIL here because it doesn't have 4 multiplications, that has 6 of them, right? But you know the procedure. So we have 8t to the power of 4, and then minus 64t to the power of 3, plus 8 times 12, 96t, and now negative 1 times t cubed, negative t cubed, negative 1, negative t squared, positive 8t squared, negative 1 times 12, negative 12. Now we'll continue with the next group of terms. This is pure FOIL. So 4 times 3, 12, t to the 4, and then minus 4 times 16, 64, t to the power of 3, negative 3t cubed, and then positive 16t squared. Now next we have to simplify all these terms, and be very careful when you simplify terms. And what I would suggest is, as you go from this step to this one here, double check your work. It's very easy to miss out on terms because there's so many little things to take care of. They're in a certain order, and always try to stay focused when we are repeating an order in math, because it happens very often, right? To repeat the order in a solution, right? And we have to be consistent, so stay focused and double check. 2 pieces of advice, golden pieces of advice. So we are going to start by simplifying or grouping like terms, because everything is expanded. So I'm looking into the power of 4 terms. I have 8t4, 12t4. So together they will make 20 t's to the power of 4. Next, we're going to go 1 power lower. So power of 3, as you can see here, we have 3t to the power of 3, negative 64t cubed, we have negative t cubed, we have negative 64t cubed. All of them together will make negative 132t cubed. You can use a calculator, just do the coefficients. I like to use my brain whenever possible so that my brain is always alert. But negative 64 is the addition, negative 128, and then negative 3 and negative 184, so that's how I get negative 132. And then we go with for the t squared terms. So we have a 16t squared and an 8t squared. Together will make a 24t squared. And then we have the term t, only 1 and 1 constant. So we are going to write them at the end, and voila, this would be the derivative of the function f prime t. I hope that you found the instructions useful. Thank you for learning with me. I will continue next with another example of the product of 2 functions, but when one of the product is in radical form. See you later. Thanks for learning with me again. Bye.